Thank you very much. Good afternoon, ladies and gentlemen.
Do you want to come down here?
I'm very happy and pleased to be here to have the opportunity to talk at this conference before this audience. As we know, in 6 years, the APL community will celebrate the 50th anniversary of the language. And of course, 50 years is a decent amount of time, and some programming languages have appeared and disappeared since. And sometimes one hears that APL is dead, not relevant anymore, so nasty things. And of course, I disagree, as I think everyone here would. And I would like to tell you a bit how I discovered APL for me, what I like about it, what I maybe not so much like about it, and how I ended up winning the second prize. So the titles of the first two topics are shamelessly borrowed from works of Kenneth Iverson. So my background is in applied mathematics and statistics, and my workhorse is R, which is actually quite a powerful statistical environment. It was influenced by Lisp and also by APL, and one can see it since in R the left arrow is used in an assignment operator, and another thing is scalar extension. If you apply an operation to do operands, and one of them is a scalar and another is not, then the scalar will be automatically extended to match the shape. And this influence is that R is very functional. So while working on my PhD project, which is dedicated to developing a monitoring and early warning system for financial markets, I needed a source of market data, of large volumes of market data. And the database that I got hold of happened to use KDB Plus as its engine. And as known, KDB Plus uses the Q language inside, and the Q language is a member of the APL family. So this was how I found out about Q and APL family. And after I started learning Q, I found that Q was actually not the first language of this kind, that it was a member of the APL family. And so I started to read about APL itself, found code, quad, vector, the groups, mail lists, and finally I saw the announcement of Dyalog about this programming competition. So I decided to jump in because it sounded very interesting. So first of all, what I like in APL, it is short. It is a very well-known feature of APL. The notation is very efficient. You can express many things in a few lines of code. And a feature that I probably have not seen in languages outside of the APL family is the part of speech. For example, the use of adverbs to change the meaning of functions, which was a new feature for me, not known from other languages. Another very prominent feature is, of course, vectorization. It spares loops and allows to think about a problem, to reason about a problem without going to gory details. You don't need to write loops. You can just add to vectors or do other things with it. The next feature, which was known to me from Lisp, from R, from functional languages, is defined functions, anonymous functions, lambdas, and unique to APL, defined operators that change the meaning of functions. The anonymous functions are very handy if you need a function just once and don't want to invent a name for it. And I particularly like the defined functions in APL, such features as guarded pattern matching. It allows to avoid spaghetti code. You don't need to write a lot of ifs, and the functions, you can keep functions very short. Another feature traditional for functional languages is recursion, and defined functions in APL are very well suited for doing recursion, and in particular tail recursion, which can be considered as a sort of go-to. And of course, another prominent feature, which is also known from Lisp, is lack of difference between code and data. Using the execute, you can convert data to code. You can dynamically construct code and execute it. So features of APL that I'm not very much fond of is dynamic scoping. I'm used to lexical scoping from R, from scheme. I think that it is a problem. The languages with dynamic scoping are somewhat more difficult to debug because you can't immediately see whether a variable will be seen from function deep down the stack. Another thing is that variables are not local by default. If you want to make a variable local in this function, you need to especially say so, to declare it as local. I would like them to be local by default, as it is done in A+ already. The next feature, or misfeature, is, I think it is a flip side of dynamicity, of interactivity, is lack of type checking, which can bite in large projects where a program can stop to run in some deep function because an argument that has been passed does not match the type that was expected. Finally, another thing that bothers me is the two index bases, 0 or 1, and I really believe that the APL community should unite on one base, and I would suggest 1.
Yeah, I think 1 too.
Well, I think there are reasons. When we work with pointers, as in C, of course it is logical to begin with 0 because it is more easy to address memory. But if we count things as in R or in statistical problems in general, then it is logical to start with 1 because number 1 is the first thing in the collection. So now I shortly present the assignments, the tasks of the Dyalog competition 2010. It was very nicely worded, and I even had to spend a bit of time casting these problems into more into form, into a more formal into a formulation. So the first assignment was to pass an XML string, and it's actually boiled down to finding a function in Dyalog APL that simply implemented this functionality. This was not very difficult. We just needed to index a nested array to extract parameters from it. If I'm not mistaken, there were 12 parameters altogether that were used in the model. So the second task was, actually it boiled down to computing an annuity with a fixed interest rate, or rather two annuities. One corresponded to buying a house and another one to renting a house. And the question was whether it is, or in how much time is buying a house cheaper than renting it. The next task was to aggregate series in a user-defined way, which meant that a user provided a size of an aggregation chunk and a character vector which specified the function, the aggregation function. And so the task was to aggregate series and predict the answer. The fourth task was goal seeking. One of the 12 parameters was replaced by a question mark, and the task was to identify this parameter. So actually basically to solve the optimization problem or goal seeking problem. The fifth task, which was a bit more complicated and a bit more interesting, was to simulate many times an annuity with a floating interest rate. This floating interest rate was random. There were random increments of the interest rate, and one should answer the question whether it is cheaper to buy an annuity with a fixed interest rate or with a floating, with the random one. And the final assignment from the list of the main problems was to do the same, but quickly, as quick as possible. There were bonus problems, additional problems, but I was too lazy, or rather I didn't have time, so I didn't do them. One was about graphical representing the results of the main assignment, and another set of problems were Rosetta problems. I hope maybe other speakers will tell more about these problems. So I would like to show a small snippets of code, only 3 examples, don't worry. I'm kind of proud of my approach to solving the problems in this way. So the first is how I solved the aggregate series problem. Here I used such features of APL as a dynamic defined operator with guards and defined functions. So in this case, there is a NP is a list, one can say, of two elements. One of them is the size of the aggregation chunk, and another one is a character vector that specifies the aggregation function to be applied to the data that are stored in the X. And here, first I defined an operator which used a guard here. So it handles a trivial case when the vector X consists only of one element. And so then come several aggregation functions, the sum, the maximum, the first value, the last value, and finally the average value. And at last, what I'm a bit proud of, I came to the idea to generate code dynamically, to use execute to execute the code that I just constructed. So that worked quite well, and the function turned out to be short. I think this is actually the whole of it, the whole function. Another thing is with the variable risk, it was an annuity with a floating interest rate. Here I use again a defined function with guards, and here I use the guard condition as a terminal condition for the recursion. So here I check whether where I can immediately return the result, and if not, then I call this. The function calls itself again, so it does the recursion. This is actually quite simple, but I find it elegant. It is a very Lisp style. Finally, the third and last example is the solution for the sixth problem, need for speed. The solution has to be as fast as possible. So here I confess I applied a dirty trick. Of course, an interest rate cannot be negative. Sometimes it can, but we don't consider such pathological cases. The statement of the problem was that the interest rate should be non-negative. And I actually computed the increments, the random increments to the interest rate without a loop in one statement. And in this case, it is possible that the increments are always negative, and finally the interest rate is negative as well. Of course, this would not be a valid solution. That's why I'm checking for the interest rate not to be negative. And if it happens that it is negative, then I compute it again using a loop. Of course, in the unfortunate case, I would have to throw away the work done in the first line and to start over, and I would lose time. The function would not be that fast, probably. But it seems that I was lucky, and this is exactly the function that was the fastest one among all competitors. I'm happy that it worked. Although I must admit that whether it is fastest or not might depend on the parameters. How much positive the interest rate at the beginning was, and also some other parameters. So I would like to say a few good words about Dyalog APL. I actually liked this environment, this translator. Actually, I'm used to Emacs, which is quite Spartan, as you might know. But I really like the integrated development environment of Dyalog, particularly looking up variable values by hovering with the mouse over the names of the variables. It is a thing that I was lacking, that I was wishing to have. And another feature which is linked to a MS feature of APL that every local variable should be declared, so is the highlighting of global variables in the editor, so that you can see immediately whether there are some rogue local variables that were not declared as such. I also like a decent amount of documentation that is available for Dyalog, and I, of course, immediately downloaded Mastering Dyalog APL by Bernard Dupont as soon as I found out that it is available, and read it with great pleasure. And I also like to say that I like very much that Dyalog APL has batteries included, so to say. There are workspace packages for version control installed, for diagramming for graphics, Rain or Rain Pro, And for connectivity, for network services, which is now called Conga, I think in my version it is not still called that. And there are also a decent amount of other workspaces that are rather interesting and enlightening. They were so for me. So I would like to thank Dyalog for providing this interpreter for free for students, for organizing the contest, for inviting me to this conference, and I also would like to thank all the organizers of the conference for making it happen. It was very interesting and enlightening for me. And finally, I would like to thank the audience for your attention.